In this video I want to show you a quick example of doing encrypted network programming in Chicken Scheme, because this is something I recently wanted to do. I wanted to try out something, and I thought to myself, well, how can I do network programming in Chicken, and how can I do it with SSL encryption? And there luckily is a openssl egg, so an extension you can install for Chicken Scheme, or a library. And yeah, I will show you how to use that in this example. So on the left I have the server, so this is my server.scm with the corresponding server process running, so the REPL. And on the right I have the same for the client, so the client code and the client REPL. And I will just real quick exit these so we can kind of start from scratch. Yeah, so alright, let's start these again. And so now, in both cases, we import the openssl socket, and I have the documentation page, not here, but here, for the openssl egg. So these are bindings to the openssl library. So by the way, you can install these with chicken install -s. If you use doers like I do, you need to do this and then openssl. So that's it, pretty simple. And I think you will need to have the openssl library installed on your system, so through your package manager. And yeah, this will also give you the openssl command. So if I call this, it will give me a bunch of output, but we will also need this, because the first thing we will actually need to do is, before we do any Chicken Scheme stuff, is generate a certificate. Certificate, if I can speak. And because I don't think you can do this through the Chicken Scheme library. I don't think you can generate a certificate here. Generate, no, these are for Cypher stuff, yeah. So I don't think you can actually, or at least I haven't found a way to do it. So I simply looked up openssl generate certificate, and I found this command right here. So if I run this, it will generate a certificate, and it will let me, because I have one here already. So if I run this, it will do crypto stuff, and then it will ask me a bunch of questions like country name, state, province, locality, and these will all be stored in the certificate, of course. And this will be a self-signed, or how's it called? Yeah, I think self-signed certificate. So this will not be signed by any. So you will actually not be able to use this for your web server or whatever. And we will actually, when we get to the client, we will actually not verify the certificate. So this is what this, I will spoil it. This is what this verify false stands for, because again, this is not signed this is not signed the way, for example, Let's Encrypt certificates are signed. All right. So, but let's just get into that. So run this, and you will have in your directory a example.crt. So this is the public certificate, and an example.key. So this is your private key. You will want to keep this private, and this you need to, of course, publish. Well, you will automatically publish it, or your server. So, but let me simply go through this. So for the server now, we import openssl socket, because again, there are a few different kind of subsections for this openssl. So there's, for example, also openssl cipher for cipher stuff, but we care about socket because, yeah, this is what we're doing here. So where is it? Where's the start of this? Yeah, openssl socket. So import this, and then the first thing we will need to define is a listener. So a listener binds to a port, and then you can actually accept, by using SSL accept, you can accept connections from this port. So yeah, this is what I do here. So we need to call SSL, let me make this a bit bigger, SSL listen star. There's also a version without star, but this is kind of outdated. And then we will pass it a bunch of stuff. So port I have defined up here, 8324, doesn't really matter. Then the protocol, we will use SSL max protocol, and if we, so let me actually go through this. If we look at that is TLS version 1.3, and we will also want to enable, or in this example, I also enable TLS version 1.2. because in the documentation we see an example, and in this example they do it like this. So TLS version 1.2. Yeah, okay, it's in some example. So I just copied that. Yeah, down here it is. So for, I guess, backwards compatibility reasons or whatever. All right, but that doesn't really matter. So we then load our certificate. We just pass the path to the file, which is in this .. because the server is located in this. If I go back here and if I do tree, we see my server is located in the server directory, so I can have two separate REPLs for this, because you'll see in a second. So we need to pass the .. to go one directory up, and the same for the key. So for the private key. All right. With this, I tried something out, but that doesn't really work with my client. And this was where I was having problems, because the listener itself doesn't really do anything. So if I just evaluate that, nothing really happens. Of course, our listener is defined now. If we call that, we see openssl.socket SSL listener. Okay, great. But that doesn't really do anything. What you need to do with the listener, you need to pass it to SSL accept, and this will now actually accept the connection. If I evaluate this now, this will block, and it will block until there is a connection attempt. And after that, it will give us two ports: one input port for, I guess, writing, and one output port for reading. Or I think it's the other way around. Yeah. So with output 2 port, yeah, output is for writing and input is for reading. Yeah, I always find that kind of confusing, but whatever. So, and we can then simply write and read from these ports. Oh well, I guess it's confusing because I have named these the wrong way, but whatever. So, yeah, we can then actually, like, if we call display with this, it will actually write to our client that has connected, and if we read, it will actually, read input. So if I now evaluate this, you will see nothing will happen, but if I now, for example, input something, so this is blocking now. It doesn't really give us, or not really, it doesn't give us anything back. If I now call, I have this, where is it? OpenSSL, it's right here. If I now call this command, OpenSSL s client connect to my server, this will now, it will try to connect, but it doesn't, again, do anything because there's something wrong with this example. So this didn't really, oh no, sorry. There's nothing wrong with this example. I simply need to import the stuff. So let's try this again, because I think this example worked. Yes, so this works. If I call it from the shell, but if I call it with this client chicken scheme code I have here, it didn't work. I don't know why. But I'll show you what does work and what you'll want to do, because this is kind of a stupid toy example. Because hello back, let's write this and let's quit. Yeah, so this is just, I tried out how this accept thing works. Oh yeah, pretty print. Yeah, we need to also import that. So let's import this pretty print. Not like that. I just want to show you. So this is blocking again. If we call this again, it will do the whole, and you can see that up here, there's this whole OpenSSL handshake thing going on. Of course it is, because again, we're using OpenSSL. So our server gives us back hello world, also hello world, and we now give it back hello there, I don't know. And if I now press Ctrl D, it will tell us done, and it will actually send this over, but nothing else. So yeah, okay. So enough of this example. This is kind of broken, but it kind of shows how this is supposed to work. But again, you will not want to use this because, I mean, this is, if it were to work, it would be good for one connection and not much more. So, and this is also blocking. So while this entire code block is running, you cannot accept any other connections with this example. So again, stupid example. What you will want to use is a actual server which spawns a thread for each connection, which can handle multiple connections simultaneously and all this kind of stuff. What I decided to use for this is a chicken egg called TCP server. So this is a, well, TCP server. So it is pretty much what we want to use, except that we will need to kind of tune it for SSL. And this is exactly what I have done. So if I just cancel that, and yeah, so let me first go through the server example, and then I will show you the chicken scheme client code. So we import TCP server because that's the egg, and it's a pretty simple egg. I mean, yeah, let's go through it. Why not? .cache chicken install and then TCP server, and in here we will find one SCM file, and there's this whole disclaimer thing. There are really only 4 things. There are 3 defined procedures, and there's one actual, like, what's it called, function or procedures. Not defined procedures, but defined variables, I guess. So, and then one constant. Okay, yeah, we don't really care about it. We care about these, well, parameters, or what they're called. So, and these now default to TCP default. So there's a built-in chicken library called TCP, and there's also a chicken egg called TCP6 for IPv6. And these provide, in a sense, the exact same things we have already seen in the SSL example. So they provide, for example, a TCP accept, which correspond to the SSL accept we have seen just a second ago. And these I will override in a second. But let me first go through this. So there's this make TCP server, and it again does a bunch of stuff. So it takes a listener, and it takes a thunk, so a piece of code it is supposed to run for each connection. And again, it's of course pretty complex, or a bit complex, but here we can see it starts a thread. So thread fork, and then it somewhere here it calls this thread fork on each connection. So here we see the same thing I've done with the server code. So we have this accept procedure. We pass it to the listener. And then we bind to input and output. And this whole thing blocks. And once it's done blocking, so once we have a connection, we actually fork the thread. And then I think this is just logging stuff. And then we loop pretty much. So yeah, again, it's of course more complex than that, but that's the essence of it. All right, so let me get back to the server, because now we actually override these procedures which are defined in this egg. So we override TCP server accept connection procedure, which defaults to TCP accept, as we have seen, and we override it with SSL accept. And I don't know why, but it kind of needs to be this lambda thing. So a lambda which simply returns this procedure. And the same thing for hard close procedure. I just passed SSL close, or I overrode it with SSL close. And the same thing we do with, or kind of the same thing we do with TCP server get addresses procedure. Because this now is a bit more complex, because there's no equivalent to TCP addresses, which is the default. So what I decided to do is, again, have this lambda, which returns another lambda, which takes a parameter, as TCP accept addresses, TCP addresses does. So this also takes one parameter, and that is a port. And then we call this not with the port itself, so this, but we call it with SSL port to TCP port. Because if we now, in our whole thing, this procedure, so this lambda will not be given a TCP port, but an SSL port. So we need to convert this SSL port to a TCP port to be then able to call TCP addresses on it. I hope that makes sense. So, and I don't know why, but I've pasted the documentation for this whole thing in here, so I kind of remembered what to do or whatever. So yeah, here it says, so if you need to obtain extra information about the connection, like for example TCP addresses, note that generally blah blah. Okay, and this is important for logging, because if you don't do this, if you don't override this correctly, you will get an error with this TCP server. All right, long tangent, but yeah. Oh yeah, and we need to of course evaluate all this stuff. So, and it will tell you, yeah, overriding blah blah. Okay, great. And then we can actually call make TCP server, pass it our SSL listener. So again, this is an SSL, OpenSSL listener, not a TCP listener. And then we can pass it a thunk, so a piece of block which will be run for every connection. And this make TCP server actually returns a procedure, so we will call this procedure with one argument. I think it's in the documentation page example, it's true. So I decided to just do this. So if I actually look this up, TCP server, of course, here's an example, and they do the exact same thing except with TCP listen instead of our SSL listener, and then also true. So yeah, and in this, the code I run here is to simply display hello world, so to write hello world to our client, and then to read from the client, and this is now an actual like scheme read, I'll show you in a second, and then to pretty print that back to the client. So let's just run this. Now it will give us actual output because again this is TCP server, this can log and stuff like this, but this will block of course again, and now I will show the client. So we can of course also now connect with the shell again, but this is probably not what you want to do, except for testing and stuff like this. So, all right. So again, we import the stuff, we set the port, and here we kind of have the same structure as in the example that didn't work. So we have this let values, and we bind input and output ports to this time not SSL listen, but SSL connect with the star. We give it a port, we give it the host name, we give it again the protocol, so SSL Max protocol is again the TLS version 1.3, and we also want to accept TLS version 1.2. We set verify to false, I've mentioned that before, so we don't want to verify the certificate the server gives us because, well, it is not verifiable because it is self-signed in this example. You could also, of course, use your Let's Encrypt certificate for this, and this would then be able to you would then be able to verify that, of course. And you can also, if I go back here, you can also pass a bunch of stuff to this. So, where is it? Yeah, here it is. So you can also pass a certificate authority directory, for example. So you could actually set verify to true, but then simply pass a separate certificate authority directory where you have your own kind of authority chain or whatever, or you can also pass certificate authorities. So you can do a bunch of stuff with this. You can also pass a certificate and a private key, and I have these simply commented out, and I think this is for like client certificates, as far as I can understand, because with SSL, OpenSSL, you can also pass a certificate as a client, if I'm not mistaken. So, yeah. All right. So we do this, and then again, this will block until it's connected. And if it's connected, or when it's connected, it will give us back input and output port. And then inside this let binding, we can actually write and read from these. So, yeah, let's just run this and hope it works. Of course it doesn't. I think, yeah, read string. Okay. So we need to import chicken string, I guess. Not this. Like this. No. Where is read string from? Chicken.io, I guess. Yeah, chicken.io. So let's input this. Chicken.io, and now it should work. Hopefully. So yeah. So this output is now us. So first we write output to port. Hello from client. No, sorry. So let's go through this client output. So the first line, this hello world, is this line right here. So this is what we read from our server, I guess. I should have prepared this demonstration better. But I mean, this is not what I want to get at anyways. It's more, this is what I want to get at. So what we do is we write to this out port. So we write to our server, and what we write is this kind of this string right here. Now, this is of course a scheme list, a dotted list to be exact. This is kind of malformed, so there's white space here and white space there. And then we also write client after that. And what our server now does is it reads this form, or it reads from port, but this is now not a read string, but an like normal read. So it reads a scheme form, and then it pre-prints that back to the client. And this is now what's happening here. So it reads this form, and then pre-prints this exact thing back. And I thought this was very, very cool. And here we see the pre-printed form, which we have sent to the server. So if I now change this to I don't know, like this, and run this again, it will give us back, of course, the changed version. And that, I'm not quite sure why it gives us hello, the hello world from the, let's actually make this English, the hello world from the server. I'm not quite sure on that right now, but because it, oh no, sorry, of course I'm sure, because it does read string, and read string just simply reads everything the server gives us. So yeah, no wonder it does that. But if we would now do, for example, this, and let's also add some marker here, I don't know, for example, like this. And this doesn't work. This doesn't work because I guess the read string is blocking our output. So yeah, I haven't, as you can see by this very bad demonstration, I haven't experimented with this too much, but yeah, these are kind of the basics, and which I had some problems with this SSL accept, and also with setting up the TCP server and stuff like this. So maybe we shouldn't call read string but read line, I guess. Is this defined? And then it shouldn't block. Yeah. So if we do this, this should now work, because read string of course blocks and waits for more input, but this shouldn't. So yeah, now it works perfectly fine. If I kind of improve the marker, it's even easier to read. So let's do this, and let's do this. So first we read the hello world, which our server gives us. Then we write this wow from client thing with the kind of scheme list form. Then we output our marker, okay, marker here, and then we read another line, and this is now this pretty print statement from the server. So yeah, as you can see, it's pretty easy to write some server client application with SSL encryption in Chicken Scheme. It's actually pretty, it's not that difficult if you use read line and not read string. And yeah, these are kind of the basics. Yeah, it took me a bit to figure out this TCP server stuff and how it all kind of fits together. So I wanted to share in this video. And I hope this was helpful. I couldn't find anything else on the internet on this. So an actual example, because in the openssl, I mean, there are examples if we scroll down, but these examples are only for like using a web server. So this is for Spiffy, this is for Awful. I think Awful is a kind of, not a web server per se, but a kind of more elaborate, like web framework thingy, or web server. Yeah. And there's also an example for using this library to do a encrypted request, or to request an HTTPS site. So, but there are no examples of actually like simply doing TCP communication encrypted. So I was kind of missing that, and it took me a bit of playing with this to figure it out. So, but I hope, yeah, not but and I hope this was useful, as I said. So yeah, that's pretty much it. That's all I wanted to share in this video, and yeah, have a nice day.